right, so they give you this differential equation, and it does have an x and a y, but it's not too bad. It's not like super complicated. On the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. So you only have to put slopes where they put points. And you can knock out a whole lot of this at once where the zero slopes are. Anywhere that x or y is 0, you're going to get a 0 slope. So you can put 0 slopes on all of the axes points, which makes them kind of harder to see. But so look, I knocked out like more than half of it just with all the 0 slopes. So for what's left, we've got -1, 1. If you plug in -1 for x, +1 for y, you're going to get -1. This is the point 1, 1. So if you plug in 1 for x and 1 for y, that's going to give you +1. Here we've got -1, -1. So if you do that, the negatives are going to cancel. So you're going to get +1. And for 1, -1, you are going to get -1. So that's cool. Looks like a bullseye or something. I don't know, kind of like that. That looks cool. Or maybe like if you turn it this way, it looks like a compass. I don't know. I'm always looking for things in the math problems. All right, so that's it. Letter B, it says find d squared y dx squared. All right, so hey guys, let's review that. What does that mean when you have all those 2's in there? Because it's not the derivative squared. What does this mean that they're asking us for? And I'll write it a little bit bigger so you can see it. What is that asking for? And good, that was right. I was waiting to see if anybody else answered me there, but good, it's the second derivative. All right, so this is the first derivative. We're going to do the derivative of that to get the second derivative. So hey, everybody, let me try and wake you guys up, get a few more answers. You all answered about SpongeBob. Let's answer about this. We're multiplying the x times the y cubed. So what rule do I need to do that derivative? We're multiplying, which derivative rule is that? And we are going to need power rule too at one point, but it is product rule. When you're multiplying, you're going to have a product rule, but we are going to need power rule as well. All right, so this is x times y cubed. We have x's and y's kind of all mixed together there. So it's going to be implicit differentiation. Whenever you do a derivative of a y, you have to multiply on dy dx. All right, so buckle up, here we go. First is x. So first times derivative of the second. That would be 3y squared dy dx. This is a good review. All right, so first times derivative of the second plus the second times derivative of the first, and derivative of x would just be 1. Now it says find this in terms of x and y. So that means for this dy dx here, you have to replace that with xy cubed. dy dx is xy cubed. So I'm going to replace that with xy cubed. And I'll just write that as plus y cubed since it's times 1. Now that's correct for the second derivative. So you don't technically have to do anything else, but I am going to simplify this down a little bit more because we have another step to this problem that we're going to have to answer a question. I just want this simplified a bit more. So if we multiply this together, this is going to be 3x times x is x squared. And then this would be y to the 5th, and then plus y to the 3rd. All right, so there's our simplified second derivative. All right, so we found that. Then it says determine the concavity of all solution curves for the given differential equation in quadrant 4. All right, now let's review concavity. I'm going to pull out my favorite stick-it note here. All right, if our second derivative is positive, that means concave up. If the second derivative is negative, that means concave down. Now they said in quadrant 4. So in quadrant 4, x is positive and y is negative. So in quadrant 4, you've gone to the right and then down. So x is positive, y is negative. So the second derivative is, and let's see if it comes out positive or negative. You plug in a positive number for x. Actually, it almost doesn't even matter for x because when you square that, that's going to be positive anyway. Times 3 would be positive. So all of this is positive. But if y is negative, you do a negative number to the 5th, that's going to be negative. So that turns this whole first part negative plus, and then again, if you plug in a negative number for y and cube it, that would also be negative. So you have a negative plus a negative, which would be negative. So in quadrant 4, x is positive, y is negative. If you evaluate x being positive and y being negative for this, you get a second derivative that is negative. So solutions are concave down in quadrant 4. So we got the second derivative. Now we didn't plug in actual numbers. I guess you could make up a positive number for x and a negative number for y if you'd rather deal with like actual values. But we got that the second derivative was negative, so the solutions are concave down in quadrant. All right, and then part C, find the particular solution with this initial condition. So let me rewrite the problem from up above on the paper so we can see it. It's xy cubed. So we're just going to solve that. So separate the variables, do the antiderivative, plug in your initial condition, and then solve for y. So we're going to divide this over. When I divide over the y cubed, it's going to be y to the negative third dy. And then we're going to multiply over the x, so equals x dx. All right, and then antiderivative, you're going to add 1 to the power, so that'll be negative 2. And then out front, we need the reciprocal of that. So negative 1/2 y to the negative 2 equals, this antiderivative is 1/2 x squared, and then plus c. Next, you want to plug in the initial condition. I am going to fix this negative exponent first. That negative exponent means that needs to come down to the denominator. And it's just worth it to take a second and do that step so that when you plug in, you aren't dealing with a negative exponent. So we're going to plug in 2 for x, negative 1 for y. All right, so if x is 2, 2 squared is 4, half of that is 2. Y is negative 1. So negative 1 squared would just be 1 times 2 is 2. So this would be negative 1/2. And then we're going to subtract over the 2. So that would be negative 2 1/2, which would be negative 5/2. Or you can write negative 2.5, whatever's your preference for that. So we're going to recopy this line and plug in the negative 5/2 for C. And then the last step is get y by itself. Now here's what's going to happen. The y squared gets multiplied over and all of this gets divided over. Oh wait, I lost something here. Didn't we have a 2? Oh, I forgot about that 2. Copy error. I'm sorry, copy error. There's a 2 there. I was going to say, I feel like something's missing. I need that 2. I'm so sorry. Copy error. I caught it though. All right, this y squared is going to get multiplied over, and then this 1/2 x squared minus 5/2 is going to get divided over. So these two things I have in parentheses are just going to switch places. So again, the y squared gets multiplied over, this quantity gets divided over. And then your last step is to square root. And if it was the general solution, you would put plus and minus. We want one specific solution. It comes from your initial conditions y value. That output is negative, so we want the negative square root of all of this. And you can leave it exactly as it is, but I'm going to distribute this 2 simply because that's going to cancel out with those and it'll be a little bit less right. This will just be x squared minus 5. All right, so to recap the steps, separate the variables, integrate, so do the antiderivative, put a plus c, plug in your initial condition, and then solve for y.